Today I have given first problem. You see, write the dual of the problem. So min z equal to twice x2 plus 5x3 such that x1 plus x2 greater than or equal to 2, and then twice x1 plus x2 plus 6x3 less than or equal to 6, and next constraint is x1 minus x2 plus 3x3 equal to 4, and x1 comma x2 x3 greater than or equal to 0. So first you see the problem. Our problem is minimization problem. Okay, and here constraint are here mixed means what? First constraint is here inequality symbol is greater than or equal to, next one is less than or equal to, and third one is equal to. Okay, so when we one linear programming problem is given, and first when ask question write the dual of the following problem. So first we check whether the given linear programming problem is standard primal form or not. What do we mean by primal? The supplied problem or given problem is called the primal, means original problem is called the primal. So here given problem, this is called the primal. So from this primal we shall convert it into the dual. Okay, so what is the standard primal form? If objective function is minimization, then all constant sign should be greater than or equal to. Anyone is less than, you make it into the greater than. Okay, by multiplying minus 1 by both sides. So first you see here we check the standard primal form. So first line I have given, first we shall write the given linear programming problem, given problem in the standard primal form as follows. Okay, since it is minimization problem, comma, all the constraint must involve the sign greater than or equal to. Okay, so here you see first constraint is what? Sign inequality symbol is greater than, and second constraint is less than. So second constraint we make it into the greater than symbol by multiplying both side by minus 1. Okay, and next one is what? Third constraint here equality symbol. So how to write the third constraint? Arbaj, how to write the third constraint? Roshni, I am audible.
Yes, sir, you are audible.
Okay, so third constraint, how to write? If equality symbol, then how to write? Ripon, if equality symbol is present, how we make it into the inequality? Suppose x equal to 2, then how to write its inequality? Ishita, anybody?
So we have to use greater than equal to
Less
and
than.
less than equal to.
One is what? One is greater than or equal to, and another one is what? Less than or equal to. Everyone clear? Means what? One constraint will be x1 minus x2 plus 3x3 greater than or equal to 4, and then x1 minus x2 plus 3x3 less than or equal to 4. Yes, good. Clear this one? Ripon? Then you see, first here what we do next, we multiply the second constant. In the second page you see, multiply the second constant by -1. Okay, so then the second constant will be minus twice x1 minus x2 minus 6x3 greater than or equal to minus 6. And third constant is inequality, is an inequality, we replace it by two constant, means what, x1 minus x2 plus 3x3 less than or equal to 4, x1 minus x2 plus 3x3 greater than or equal to 4. Okay, then here we make it into the standard primal form. So it is the minimization problem, all signs should be, inequality symbol should be greater than. So here in the third constant you see, one is less than, one is greater than. So less than symbol where present, you make it into the greater than symbol. In the second page you see. So uh, so in the third constant here, the first one multiplying by -1 reduced to minus x1 plus twice x2 minus 3x3 greater than or equal to -4. In the second page you see. Okay, so here we get all the constraint. Okay, so the given problem in the standard primal form is as follows. Okay, so primal is given what, mean z equal to twice x2, means x1 is absent, so we write 0 into x1. Second page you see, plus twice x2 plus 5x3, so we can write into the vector format 0 to 5 x1 comma x2 comma x3, means 0 into x1 plus 2 into x2 plus 3 into x3. Then you can give the name, this is c and this is denoted by capital X. Next, you write all the constraint. First constraint will remain same, means what? X1 plus x2. X3 is absent, so 0 into x3 greater than or equal to 2. Minus twice x1 minus x2 minus 6x3 greater than or equal to minus 6. Then minus x1 plus x2 minus 3x3 greater than or equal to minus 4. And then x1 minus x2 plus 3x3 greater than or equal to 4. Okay, so next you write these inequalities into the matrix form. So you write all the coefficient of x1 x2 x3. Okay, greater than or equal to, right hand side constant are 2 minus 6 minus 4 4. Okay, so you can write this is ax greater than or b. Okay, without giving, you can directly write greater than or equal to this. Okay, then we write its dual, right? So dual will be what, minimization problem, then its dual will be automatically maximization. Okay, by the how to convert primal to dual procedure last class I have given. Okay, so makes zd equal to, then what we write, we write in this way, constant of the objective coefficient of the objective function and constant are replaced. Okay, so here constraint constants are what, 2 minus 6 minus 4 4. So this is, you write in the, this will be the coefficient of the objective function. So 2 minus 6 minus 4 4. Then here you see, we write W1, W2, then W3 dash and W3 double dash. Okay, so here you see, you go to the original equation, primal problem, you see, first constraint symbol is greater than or equal to, second constraint symbol is less than or equal to, and third constraint symbol is equal to. So here how many, here how many equality symbol present in this equation? One equality symbol present in the constraint. So we get one unrestricted in sign variable. Okay, one unrestricted variable. So for this reason, we write third variable will be w3 dash and w3 double dash. So you say this line is clear or not? Up to this clear?
Yes, sir.
Okay. Okay. So here you see when we write unrestricted variable or unrestricted in sign means when we get here you see how many unrestricted variable or unrestricted in sign. This is depends upon the equality symbol. If the constraint contains one equality symbol, then we get one unrestricted in sign. If the constraint contains two equality symbol, in the two constraint are given equality symbol, then we get two variables are unrestricted in sign. Okay, because you see here original primal problem, in the primal problem here given three constraint and one is equal to symbol and remaining are one is greater than one is less than. But when we convert it into the standard primal form, then we get what from 3 to 4 one one constraint like what equal to symbol can be written as greater than and one is less than. So this is adjusted by the unrestricted variable or this is unrestricted in sign. So w3 dash and w3 double dash we use. Okay, so such that then we write transpose of the coefficient matrix. So what will be the transpose of the coefficient matrix of the primal? So coefficient matrix of the primal is given, we have written, so its transpose will be rows and columns are interchanges. So first row of the primal will be first column in the dual. Second row of the primal will be second row of the second column of the dual. Third row of the primal is third column of the dual and fourth row will be fourth column. Okay, so here in row wise you see 1 minus 2 minus 1 1, in the third page you see then 1 minus 1 1 minus 1, then 0 minus 6 minus 3 3, and this is automatically w1 w2 w3 dash w3 double dash. Then this part will be the coefficient of the objective function. So primal objective function coefficient is 0 to 4, so we write less than or because here greater than or equal to symbol present in the primal, so when we write it into the dual then reverting the sign. Okay, so this is less than or equal to, so this is 0 to 5. Okay, so next you just simplify w1 minus twice w2 minus w3 dash minus w3 double dash less than or equal to 0, then w1 minus w2 plus w3 dash minus w3 double dash less than or equal to 2, then 0 into w1 minus 6w2 minus 3 into w3 dash minus w3 double dash less than or equal to 5, then w1 w2 w3 dash w3 double dash greater than or equal to 0. So here you see we write, here you see unrestricted variable we denoted by w3 and this is the difference between w3 dash and w3 double dash. So writing w3 dash minus w3 double dash equal to w3, then the dual problem is just makes ZD denotes dual. Okay, so equal to twice w1 minus 6w2, then minus sign common 4 w3 dash minus w3 double dash is w3, so 4 w3 minus 4 w3. Similarly, such that w1 minus twice w2 minus sign common and this is W3 dash minus W3 double dash is we write W3, so this is W3 less than or equal to 0. W1 minus W2 plus W3 less than or equal to 2 minus 6W2 minus 3W3 less than or equal to 4. Okay, so and W1 W2 greater than or equal to 0, and here you see W3 is our unrestricted sign. Why? This is one equality symbol present, so we get one unrestricted sign. So clear this one?
Yes, sir.
Yes, sir.
Ishita?
Yes, sir. Yes, sir.
Okay. Roshni, clear this problem? Here you see, next question is what? Next question is, give the dual of the following linear programming problem and makes z equal to twice x1 plus 3x2 plus x3 such that 4x1 plus 3x2 plus x3 equal to 6 and x1 plus twice x2 plus 5x3 equal to 4. x1 comma x2 comma x3 greater than or equal to 0. So in dual, we get how many unrestricted in sign? Means unrestricted variable, we get how many unrestricted variable in this problem? Anybody?
Sir, 2.
Yes, two unrestricted variable. Why? Because here two equal to symbol present in the constant. So we get two unrestricted in sign. Okay, earlier one is one equal to symbol present, so one unrestricted in sign. So first here what is given? Makes z equal to twice x1 plus 3x2 plus x3. Okay, so our problem is maximization problem, so all constraint sign should be less than or equal to. Constraint must involve what? Less than or equal to symbol. So first, from first equation we get two inequality. From the second equation we get another two inequality. Okay, so here maximization, so all constraint sign should be less than or equal to. So where greater than symbol present, then we multiplying both side by -1. Okay, so here you see first constraint, uh, I have written in the solution part. You see, first we shall write the given problem in the standard primal form as follows. Okay, so next one is, since number one, since it is maximization problem, so all constraint must involve what? Sign less than or equal to. And number 2 point is the first equation is equivalent to what? First equation here equivalent to 4x1 plus 3x2 plus x3 less than or equal to 6, and we can write 4x1 plus 3x2 plus x3 greater than or equal to 6. And second constraint of this, we here what? Second constant we have written greater than or equal to 6. Okay, so multiplying both side by -1, then this gives us less than or equal. So multiplying both sides by -1, then the second equation, constraint second equation is equivalent to, we can write x1 plus twice x2 plus 5x3 less than or equal to 4, and x1 plus twice x2 plus 5x3 greater than or equal to 4. So greater than symbol, we make it into the less than by -1. So minus x1 minus twice x2 minus 5x3 less than or equal to -4. Okay, thus the given LPP in the standard primal form is makes z equal to, first you write in the vector form system, so twice x1 plus 3x2 plus x3 equal to 2 comma 3 comma 1 and x1 comma x2 comma x3, such that you write all the constraint. So first one is less than or equal to 6, second constant is less than minus 6, third one 4, fourth one is minus 4. Okay, so next you write is coefficient matrix. In the matrix form first you write, so we write the matrix form. Then how to write its dual? So the dual of the given problem is, our problem is maximization, so its dual will be minimizing d, so mean zd. Then you interchange the coefficient of the objective function and constant of the constraint, interchange. So constraint of the constant is 6 minus 6 4 minus 4, so we write 6 minus 6 4 minus 4. Then we write here two unrestricted variables, so we denote w1 dash, w1 double dash, then w2 dash, w2 double dash. So we multiplying this, we get 6w1 dash minus 6w1 double dash plus 4w2 dash minus 4w2 double dash. Okay, then you write the transpose of the coefficient matrix. So transpose of the coefficient matrix will be what? In the primal, first row will be in the dual first column, second row of the primal will be second column of the dual, third row of the primal will be third column of the dual, fourth row of the primal will be fourth column of the dual, and variable we used w1 dash, w1 double dash, then w2 double 1 dash, w2 double dash. Then inequality symbol in the primal is less than, so its dual will be automatically greater than, reverting. If less than, then this dual will be greater than or equal to. Then we write the coefficient of the objective function of the primal. Coefficient of the objective function of the primal is 2 3 1, so we shall write 2 3 1. Then just use simple multiplication, we get this constant. Okay, then w1 dash minus w1 double dash can be written as w1, and w2 minus w2 dash, they are here missing w2 dash, so you write w2 dash, w2 dash minus w2 double dash equal to w2. The dual problem is then mean zd equal to, so w6 is common, w1 dash w1 double dash minus w1 double dash is w1, so 6w1 plus 4w2, then such that again from the constraint 4 is common, so 4w1 plus here w2, then greater than or equal to 2. Next second constant 3 common, so 3w1, then 2 common plus 2w2 greater than or equal to 3, then w3 plus 5w2 greater than or equal to 1. So here w1 w2 both unrestricted in sign. So in this way we convert from primal to dual. Okay, so clear everyone?
Yes, sir.
Yes, sir.
So here you see sometime what happen, you directly after practice this problem, you will try to write directly from primal to dual without writing these languages we shall write, because in sometime what happen, using dual solve the linear programming problems, then we write what we, without writing this coefficient matrix or etc, we try to directly write the, from seeing the primal we shall try to write the dual. If you find difficulty, then you proceed in this way up to this. This means what? Some lengthy. This will be some lengthy. Calculation will be more. Okay. So this is the conversion of primal to dual. So here one important question in your exam is what? Right, how to convert one primal problem to dual problem in the linear programming problem. So this is, then this is one question, and another important question is write the standard primal form. There are 2 points you will see. what will be the standard form of the prime view. রিপন বুঝে পেছানে
max max ZD value such that it is sir like A transpose এটাত ফার্স্ট ইকুয়েশনটোত লেস দেন ইকুৱেল টু লিখিছিলে এটোত গ্ৰেটাৰ দেন ইকুৱেল স্যাৰ ৰিজনটো অলপ কনফিউজন লাগি আছে বুজাই দিব যেন
এটাত লেস দেন এটাত গ্রেটার দেন লিখিছো আচ্ছা মানে ax গ্রেটার দেন অর ইকুয়াল টু b আছে না নিহাল
yes
is
sir
it okay and then you see the dual of the given problem ax greater than or equal to b up to this is the primal up to this is the problem of primal. Next, you see I have written the dual of the given problem means A2 problem or dual to start all. So what will be its dual? Primal objective function is mean. So dual objective function is max. So I have written max ZD. Okay, equal to B dash W. You without writing B dash W, you write directly. This one will be equal to what? Then constant of the coefficient of the objective function and constant of the constraint are interchange means what constraint of the constant of the constraints are what 2 minus 6 minus 4 4 are the constant of the constraint in the primal or constant বিলাক কি আছে primal or constant বিলাক আছে 2 minus 6 minus 4 4 then this will be interchange with the coefficient of the objective function means what then this will be the objective function of the dual means 2 minus 6 minus 4 comma 4 then w1 w2 w3 dash w3 double dash next one will be what inequality will be in the primal inequality is greater than or equal to present then its dual will be less than or equal to তোমার এইটো how to convert primal to dual last point to আছে reverting the থার্ড পয়েন্ট নেকি রিভার্টিং দ্য ইনইকুয়ালিটি সাইন প্রাইমেলত যদি গ্রেটার দেন থাকে ডুয়েলত লেস দেন হ'ব ডুয়েলত যদি লেস দেন থাকে প্রাইমেলত গ্রেটার দেন হ'ব চোৱাচোন বুজি পাইছানে নিহাল
yes sir got it
আৰু কাৰো যদি এইটো প্ৰবলেম থাকে যে ax গ্রেটার দেন b লিখিছো এইটো নিলিখিলেও হ'ব দিস ইজ ক্লিয়ার এয়া b dash w এইটো নিলিখি কিনি ডাইৰেক্ট লিখিব পাৰা here just we have written and here you see a then its transpose is here we consider a dash okay